In this video, we're looking at problem 827, present value of an annuity due, which works basically the same as the present value of an annuity. The reason we know it's an annuity due is because when we read a problem, Leon has a debt. He's borrowed some money that he's making a payment of $1,300 a month, and he's going to have to make this a payment every month for 15 years. His interest rate is 6%, and he's mailing his first payment in today. So he's making his first payment at the beginning of the month versus the end of the month. So if we look at it, if we compare, and I've put in different numbers here, but we can still compare the present value of an annuity with the present value of an annuity due. The way to think about this is when you make your first payment sooner, you can borrow a little bit more money and make the same number of payments if you make your first payment at the beginning of the month versus the end of the month. So the difference in the formula is, if you look at this cell right here, we're simply taking the formula for the present value. We're right here, right? If you follow the cursor up, we're taking the formula for the present value of an annuity, and in order to get the present value of an annuity due, we're multiplying that by 1 plus the interest rate per month. Which brings me to my other point here, is because he's making this payment every month, we have to calculate from the annual interest rate, we need to calculate the monthly interest rate. So I have a formula in these cells right here that divide the annual interest rate by 12, so you get the monthly interest rate, and that's what we're using here for K, because for our number of payments, since it's per month, we're going to need to multiply the years times 12. So this purple cell right here multiplies the number of years times 12, which would give 20 times 12 is 240, and that gives you our number for N, which is our number of payments. So for the problem, you just simply need to put in the numbers from the scenario in the first row right down here, and you should get everything you need. So you're going to want to put in your payment here of $1,300. 15 years goes here. The annual interest rate is 6%, and I believe if you just put in, you're going to have to put in 6 and then change it. I think 6. Yeah, you got to change that to 6. You're just going to delete, and you get a 6%, and then the number of years is going to go here, and that should multiply out to give you the months here, which would be 180, and you'll be able to get your answer. And you can see that, there's very little difference between the present value of an annuity and the present value of an annuity due. It's just that 1 plus, and if you read again down here, you're just multiplying your answer by 1 plus the interest rate. So think of this in terms of figuring out like, if I want to borrow a certain amount of money, or I could say it like this. I could say, I can afford to make a payment of X amount of dollars a month, and I want to make that a payment for a certain amount of years, and I'm going to have to pay, and the cost is going to be a certain annual rate of interest, and then what am I going to be able to borrow for that, right? What I'm going to be able to borrow. So say I can only afford to make a payment of $1,000, and my interest rate was only 6% and not 12, or just say it's 5%. It doesn't really matter. And you can see that I wanted to pay it back for only 10 years. I want to be completely, no, let's just say 5 years. Say I want to be out of debt in 5 years. So let me change that to 5, and then we could say, okay, I can afford to borrow $635,000 if I pay $12,000 a month. Now, this is a good thing to use. Say you're buying a car, right? And I want to buy a car that costs $20,000 Well, actually, I want to make a. Let me back up. I want to make a payment. I can afford to make a payment of $500 a month, right? And I'm going to be able to get an interest rate of, let's say, 3% a year, because interest rates are low right now. So let's just say that's going to be a 3% a year. And I want to have my car paid off in 4 years. Oh, by the way, if you go right here and you just click this little, you can see where this is actually dividing this by 12 right here. So, because if we divide 3, let me just show you so you'll believe me. If you divide 3 divided by 12, you get, let me pull it down so you can see it, you get 0.25, which is what we have right here. So that's our monthly interest rate right there. So anyway, if I can afford to make, if I know I can afford to make a payment every month of $500, and I'm going to get my car paid off in 4 years, and I'm going to have to have the lowest interest rate I can find at my bank, I can get at my bank is a 3%. Then I can go out and afford to buy a car that costs $22,589 if I make my first payment at the end of the month. If I make my first payment at the beginning of the month, I can afford to pay a little bit more. And that is the difference. Okay.